Start now. G'day guys, how you going? Welcome to our wonderful recording. This is a live workshop and we're going to talk about introduction to game design. So let me bring up my slide and we'll get started. I might give it one actual minute just because we did say we'll start at 2 and my clock says 1:59. So you guys get to see me for a minute without me talking. Alright, it's 2 o'clock, we'll get started. Okay, so welcome. This is our introduction to game design. So what we're going to look at, and I got asked to pick a couple of topics which I like to talk about in design itself. So we're going to talk about looping, nesting loops to be more specific, and also brainstorming game mechanics. So the other design teacher, Craig Bentic, also helped, and I also did some of the slides too. So we'll start with the first one. First one more is my general thought about design. So I believe that it's more 70% communication and 30% of it is paperwork. So 30% of paperwork equals to emails, meeting notes, setting up testings and collecting data, updating spreadsheets and so on. Pretty much all the boring stuff. Whereas the 70% of communication is just not how you, the designer, communicates with other team members. But it's also a designer needs to be able to manage input from other team members and provide in short notice ideas and support with communication between everybody. So communication is also how the player reads into the level by level play. So it's not so much it's talking to people, it's more about how you would train people or how you would all aspects of the game. So the next diagram, which you can see up there, this is how you approach game design or games mechanics. So not necessarily from a point of view that it's all about the person who, but you can see it's more about you do A and B, well that happens, so then you can do C or either D, or you have a chain reaction where you got different fails or rewards. And so these things here, you can see by the diagram, you have your core loop, which goes into do A, and you can either succeed by getting that to G, which happens, with F, which fails, that fails, or F, that is the reward. Or you might have another opportunity where you're able to go through B, C, D, E, and then all loops together. So you kind of break up a game. So with that one there, we're now going to have a look at loopings. So we're going to step away from the design document. So a lot of first-time designers will spend time in developing the character, the story, or the environment. And they spend a lot more time in that area. So when we talk about how, tell us about your game idea or tell us about the game, they'll first of all go into a unique story or they'll talk about the characters. But most of the time to get an idea where as designers, we're wanting to find more about what the core loop or what the main game objectives are. So I feel that a lot of people get into character and story and environments because it's easy and the most creative part. But I kind of ask my students, well, is it the most creative part? So I like to tell my students that you need to understand from the get-go that you're not designing for yourself. Concepts and ideas may be yours, but as a designer, you are transforming the information to other streams. So artists and programmers, you learn how to write out information for them. So taking the romance out of writing. I find that, again, when students first start, when they go into design, they want to write themselves a novel, or they want to write in-depth information. So we're not writing a novel. Instead, we're developing and writing live information. So when I say live, I mean that we develop to suit others and not necessarily ourselves. But also we change how things work. So all of the design is a living and breathing document. Changes and updates will always happen. Nothing is in cement, or at least to a certain point, nothing's in cement. So you can see that I've got a couple of points like mind maps, delivering journal experiences. We'll also have an idea about that as well. We'll more or less start to, when we go further in this workshop, show you how I would go for a journeys experience when developing the mechanic. Okay, so we'll have a look at nest loops. So this is the first concept in design that I like to go through. The reason why I like this is it's probably the most easiest way to wrap your brain around a breakdown of game mechanics and also how things string together. So there are many, many different ways and approaches to do to break up game mechanics. This is one that I personally like. So you can see that it's broken up into three things: the core game loop, the secondary game loop, and the tertiary game loop. So we're going to spend a little bit of time talking about these, and hopefully I can come up with some examples which will easily be, which you can relate to. So we'll start with the core loop. So a loop is a set of actions that the user is repeating using the primary game loops. For me, a game can be put into a genre. The genre itself will have a core game mechanics that are used in similar games. So if you look at every game, like a car needs to have an accelerator. Every first-person shooter needs to have a crosshair to line up. Every football game needs to have a football. When we start to do design documents or even start to think about what type of games we want, we can take from the previous games that have been launched, and we can find what genre they fit under, and from that we can set up some core mechanics or core game loops, which we'll always find in those type of games. So you can see here that the example that we had before is also set up in there. So think of it as a lot of different core little elements which are then brought together to make a game. Okay. So then we've got a secondary game loop. So this is where you start to pull away and add in elements of design that are unique to the game. So capture the flag in a first-person shooter. In a racing game, the track itself may change depending on the outcomes chosen by the player. Role-playing games allow you to pick side missions. The most important aspect of secondary game loops are that they support the core play itself. The idea is to reward the user for using the core loop. So if we have a look at the next slide, this hopefully gives you a better visual example about how those core loops work together and how you can see that the secondary supports that. Okay, so now we're getting to our tertiary loop, and this is the big picture. So this is where you can insert completed levels, story starts, you can add in achievements, information boards. Remember that this is a simple breakdown. Tertiary is when character development, story, and all that can be put in. It's up to basically the designer to find where this works and doesn't work with your game. So the game will take on its own life and start to become its own fleshed out system. So you can insert cutscenes, you can have tournaments, as we mentioned, leaderboards. This is basically the icing on the cake. And so the next slide should give you a better example. And the branch which you can see here, this is just an example. It's not like a linear branch where you can see level 1, level 2, level 3. It's more that you get an idea about how we've broken it up into 3 parts. So again, just real quickly, we can see that you've got the core, you've got the secondary, and then you've got the tertiary. So you can see that the core is the single ideas of how these things work. Secondary is then the expansion of that. And our tertiary is how things blend together. So then there's also timing which is involved. So looping like clockwork. So again, this is more of a personal opinion. You might find that some people who are designers might vary from different opinions, and that's all good. But the way I see it is the core game loop is second to second reward. So if you have your controller with you and you tell the character to move forward, then the second reward is the fact that it's moving forward. The secondary gameplay loops is minute-to-minute reward. So a reward could be if you fire a gun and then the bullet is traveling to hit, say, a zombie, The reward is to see where the bullet actually hits or if it does hit. And then our tertiary gameplay loop is developing hours of play level to level. And so that's when you get into the whole level itself. And that's where you can start to find out where you're going to place items or have like the interaction with the character that you control in the game with what's around you. So as a quick example, we're going to look at real quickly a racing game. Now we've got Burnout 3 Takedown and we've got Mario, but I might talk more about Daytona and Mario just because Daytona is one of the games that I like. So one of the core mechanics for any racing car game, or for most of them, is there's a hidden core mechanic which is like a rubber band or a catch-up mode. So basically, you can see this in Daytona. That's why I'm going to probably talk about Daytona more. Where if you're falling behind, the car will catch up to you faster. And so it won't tell you that your speed odometer is going faster. It more like is allowing you to drive faster to a certain point and then you go back to your regular speed. And so that keeps the gameplay happening for racing car games. Okay, so racing games, we've got the core loop, which is navigating the course and maintaining lead position and the car movement itself. The secondary mechanics could be anything from the ability to boost how fast you go. So in Burnout, you achieve this by performing daring maneuvers or driving against oncoming traffic, which sounds pretty awesome. It creates currency the player can acquire, then spend ideas in developing your driving system, the style of how you want to drive the car. So Mario Kart has a racing great beat that the others need to finish. Oh, I might need to change my notes on that one. But basically the power-ups is what Mario. So power-ups is what allows you to take control of it. So it allows the player, even when they're back at the pack, to pull a neat trick and to be able to get into leaderboard. So when combined with the rubber band or the catch-up mode, this sometimes people don't like this, but it makes a nice game. It's hugely popular in the fact that even if you're coming behind, you still have chances, and you know the mechanics allow you to catch up. Okay, so this gets into balance, and so we can lay out the mechanics as much as we want. We can also say, you know, this is our core, this is our secondary, this is our tertiary, but we also want to find a balance, and we get this through test playing and so on. But the Mario balance is how many times, of some examples that could be the balance of Mario, could be how many times on the track do you get power-ups? So, or how many times do you get like little weapons like banana skins or speed-ups, or does it fire out a shell type thing? Where do you respawn if you fall off the map? Different cars and players' statuses which provide different speeds. So a car might be slower or a car might be faster. Different terrain, so you can slow down, speed up the car itself. So, and what we want is how seamless does this catch-up or rubber band thing work? And so that's where you start to find balance. And that's where, as designers, although we can write out simple mechanics and how things work and we can pass that on to the other streams, it becomes more of a fact that we want to be able to find that balance of play so it flows nice and smoothly. And so that goes down to the controlling the flow of play. So how do we control the length of a match with dynamics of the secondary loop? So when we're coming up into the design process, and some of these three questions may not even relate to the Mario game itself, but do we have a kill time limit? So Daytona, for instance, if you're playing that game, you have to get to checkpoints, otherwise the time runs out and then the game ends. So should we decide if one car has lapped everyone, say 10 times, they automatically win? So you start to put into these support mechanics about if it's going to be boring for everyone else that they know they're not going to win, then we can say, well, this person's now won the game. So do we allow each individual player a certain number of respawns as well? So you might say in your game, if you crash or die a couple of times, then it's going to be taken out. You may not be able to play, but you can watch the rest of the game. So I probably wouldn't do that in one of my games as well, but at the same time, it's something which you do consider. Okay, so that was just a quick rundown, again, of our nest loops, core, secondary, and tertiary. If you ever want to get an idea about what the level of design you can do, the best idea is pick your favorite game and start to work out what you yourself would find as your core, your secondary, or your tertiary. Make a nice mind map and spread it out as far as you can. Okay, we might now dive into mechanics. So this one's a little bit long, and one thing we find when we first start talking about mechanics, especially when we're training people about that, is mechanics is not just a simple idea of what works. You also have to think about what doesn't work, and you have to write kind of like a rule set of things, so positives and negatives. So this is a rundown of or a brainstorm of how a grappling gun could work. So it's not so much that this has been made, it's more that the designer is come up with an idea, and this is probably about 15 minutes of me thinking, but when I've added all the slides in and to show you the examples, you'll probably see it's about half an hour of information. So I'm going to run through how I think about mechanics and how I use a grappling gun. So the concept, what type of concepts have we already been made in games? And so research is a good part of it. So you can see I've got some examples of different games and then how they themselves have used a grappling gun. I'll probably call it a grappling hook as we go through it. So I researched what's already out there, what has worked, what hasn't worked. More or less this is my research process. Then I can write down the user story or the journal. So the user story is a description of one or more sentences that informs what the user does and what needs to happen. So this is talking about the grappling gun, how I might pick it up, how I'm going to use the crosshair to aim and shoot, how I'm going to use it, is it going to get put away, is it going to be activated by a button. All of these things I can write out first of all and I could even do these in thumbnails, or I could do this in a paragraph or so. I know it says one or more sentences, but it's basically giving an idea of how it's going to work and play. And it's a good step. At first, when I first started to design, I didn't quite get into this as much. I had a couple of other design people show me the importance of writing these concepts down with user stories. And I must admit, since I've started to add it in the early days, it's become quite effective. Even if you want to share your information with programmers and artists, you may not have all the information of the mechanic out. It's a good idea for the user story to show how the concept should work. Okay, so what is the core concept? So again, this is all about what I think about before I write things down. But to make it easier, I have wonderful graphs. So target A, grappling gun, to begin with, is inactive in the environment. So to activate it, my grappling gun's going to be target B. So target A, think of it as the person holding the gun, and it's going to be linked to target A. Target B shoots from target A in a forward direction, and the swing rope is in between target A and target B. So sometimes when we talk to people when they first start developing mechanics, this is what they provide us. So then we start to think about other areas of how this can be improved. So what distance can the rope extend to? So is it 3 meters? Is it 1 meter? Is it 5.5 meters? We're starting to this is going to shape how we think it's going to interact with the environment. So I chose 3 meters, just to give you a number. So once the shooting process is complete, what happens now? So again, we'll go to this slide. How does target B interact with the environment, and what are the limitations? Okay, so does target A move to target B? Or does target B move to target A? These may seem like really simple concepts and ideas, but you can already start to see this is the information that I'm laying out before I hand it to the idea to programmers or artists, more programmers because this is all about the coding. But you can start to see I'm really starting to think what is going to happen. So you could even break the grappling gun into the core, secondary, and tertiary, to see different levels. So you might start with a grappling gun that does only fire, and you might be able to swing instead of moving objects or you getting closer to those objects. So does target A swing on the pivot point of target B? When target B is attached to an item in the environment, will the item now be controlled by target's A pivot point? So parent to child hierarchy. The item becomes a child to target B. Target B is already a child to target A, causing the item to rotate on target A's pivot. So a good example would be the Spider-Man games, where Spider-Man, when he shoots his web out, and then gets to an object which you can throw to a bad guy. So if you played the new Marvel Lego game, I know it's a little old now, but it's one that I've enjoyed. To fight Sandman, Spider-Man has to shoot, and then he has to grab something, and then he throws that onto the bad guy Sandman. So you can also see how the grappling gun itself, the mechanic can be spread over to something else. It doesn't have to just be a grappling gun. And I think a slide coming up is also going to talk about that. So how much slack contention is in the rope as target B is fired from target A? So that's more of our visual type thing. And that can be important too. That can sell the idea of the grappling gun. So have you noticed that even in the concept stage, I'm using general terms and words in my writing. So instead of using the word grappling gun, I'm using target B. So I choose to do this as a perfect example just then how I talked about Spider-Man, where if I have to come up with ideas and concepts, I tend to make myself templates. And these templates can get changed with different words and different processes, but it's more to do with being able to not get that romance of writing I was talking about. It's so I can reuse things if I need to. So I tend to write with target A, target B, or very general terms, so it's easier. So if I have to have an idea for another concept or another game, but because I know the genre, because I know what core and the secondary things, you can see how I can start to use these templates to develop faster. That's probably what I'm trying to get at. Okay, so before the game is in place, the idea itself needs to be implemented. So the other streams such as art and programming need to work out the limitations of what the designer has provided. So you can see here that there's a couple of ideas which I've just thought about. So the art must be designed, database must be designed, the system needs to be designed. All of the things which are maybe outside of my control, but you can see that I'm giving a lot of information before that even they get the idea of it. So it's already mapped out and laid out for me. So we talked a little bit earlier about how we're writing for a journey. So how does the player know where to shoot? So you can do this in point form, you can do this in paragraphs, you can do this in any form you want. Because I've got a slide going, I'm going to show you guys this in a visual sense. So this is a step-by-step through. So the designer will need to inform the player how to aim to an object. So I've got my target here. B is activated, which is the gun. The player will hold down the fire button, which in turn activates the trajectory display feature for target B. So while holding down the fire button, target A's directional movement is stopped and target B's display trajectory is activated in the rotation. So while holding down the fire button, target A's directional movement is stopped and target B's display trajectory is activated in the rotation. Oops, I just said that. So you can see here that the information the player sees to show that the grappling gun can be activated is highlighted when the display trajectory passes onto an item. So the player releases the fire button, a target B shoots forward at a selected item. So when target B hits, you can see that my character from A is 2 meters away. So remember we were talking earlier about the restrictions of how far a character can move with that rope. So you can see now that he's got 3 meters while that rope is attached to target B, and he can't go any further than that. So target A can only move to 3 meters distance while it's attached to an item in the environment. So again, I'm laying out the story and the process, so if the programmer reads it, they can start to see the restrictions of what they need. So what we need to do is target B can be retracted back to target A by double tapping the fire button. So you can see here that it goes back, and then we can tell it to disappear, so now it can move freely without being interrupted. So the limitation of the rope is not in stone. It's an idea that I have. It will need to be tested in a workable prototype or an executable. The idea of it is, again, more testing and more development of it. We'll see that, maybe the rope doesn't have a distance of length. Maybe it just fires out. Kind of like, again, we'll go with Spider-Man with the Spider-Man webbing. Like it just shoots and goes forever until it hits something. So you can start to see the process of thinking. So what happens if you shoot and miss your selected target? So with this point here, you can see that at the moment, everything seems to be working fine. But now I'm going to start to do my story mode or my journal about how things miss and how things don't quite go according to plan. So you can see that an item is animated to move back and forth. The target needs to shoot the target B at the moving object. So you can see that we line up with the trajectory, as we've talked about. And then when the player releases the fire button, and target B will shoot out. So again, this is all concepts ideas at the moment. I'm laying this out before I talk to anyone, so if anyone asks me questions, I'll be able to answer about the mechanic. So the player releases the fire button, target B will fire. This example shows the timing is wrong and the player will miss. So when I thought about this, the note for later is how fast does the actual line fire out? And will this have an effect on the gameplay and timing? So it's kind of like a little side note I've asked myself as I start to plan this out. So you can see that it's missed. So there we go. It's lined up. As it fires, it misses it. So once the distance between target A and target B has gone to its limit of 3 meters, or hits another object in the environment before the line reaches 3 meters, does target B, will it automatically be retracted back to target A? As you can see, it goes back into there. Once this function or retraction has finished, the player can set up for another attempt. So again, you can start to see that when we're developing the mechanic, it's not just saying, oh, we want something to shoot. We're thinking about all the processes and all the points of positives and negatives that it could do. So that's something that's in the back of my mind, and this leads on. I'm starting to make connections to other aspects of the game development, so controller buttons. Before I do this, so you can see that button 1, it has it activate and disactivate. Tap button once to select icon weapons, grappling gun. I can also start to think about how this mechanic itself can be used for other weapons. Where button number 2 is a fire button, so press once it fires, hold down the fire button, a trajectory line will come up. If I double tap it, it retracts. So we can start to get an idea about how maybe throwing a grenade can be used with the same control setup as firing the grappling gun. So again, as designers, we're also, even at early stages, we can start to think about how things react with other things. Okay, so back to the grappling gun mechanics. So how does target A swing using target B? Now again, in this development, we may not have this swing feature, but because I have time to think about all the possibilities for it, for my grappling gun, I'm going to go as far as I can with it. And then you might find that the grappling gun itself might have upgrades, and then this is where some of those upgrades get added to. So unsure how this is going to be done, I will simply lay out as much detail as I can about the swing. So I will take this to whoever I need to, and then we can work on it together. So the way I see it is when target A falls off the edge, it will use target B like a pendulum. So once target A gets to the other side of the platform, what happens? Now when I ask what happens, it's more like, does the pendulum action keep working until the player turns it off? And if that does it, then is it going to swing back until it stops? So again, this is things which I take into consideration, even at the most basic stage which I'm playing. So when the pendulum is in action, the player can retract target B back to target A. So we already talked about the button when we double tap it. By double tapping the firing button once over the other side, it should then retract back down. So if we quickly play through those slides again, you can see that the idea is as you swing across, you then can shoot it down and it goes there and you can keep going on. How could this be a problem? How could it not work for us? So depending where I now can double tap or I can release, depending on how the pendulum moves, could mean that my character, target A, could go in all sorts of different directions. And this is where we start to now fine-tune the idea. So you can see with this slide here, as he starts to come swinging across, I double tap the button, which then releases it, and then he falls into that pit. Or if he starts to swing, and then he gets to, I do it too early, is he going to swing higher than what he should and miss the drop-off point altogether? Or if I time it correctly, is it going to work perfectly? So again, from a simple idea which we had, let's go all the way back up. And I'll run through this one real quick, you won't have to go through it all again. You can see that from a grappling gun to the concepts to then how we think about everything that's going to happen with it all the way through. So when we start to develop our mechanics, this is the process of thought. Oh, went too far. Okay, so again, I can then start to think about a different button is going to activate the pulley system now. So if you think like Batman's Batarang when he fires that out in the Arkham games and then launches himself up with his own grappling gun, and then when you hold the button down, I think he gets drawn A to B, then when you let go, you get launched further. So that's also more of what we start to plan out. So all the different considerations, the player takes for granted that the mechanics feels right. However, you can see that with the thinking and complexity taken into development of one simple mechanic, how we need to stay on top of our game. So this is just one simple mechanic on its own, and you can start to see how the designer needs to apply forward thinking to all aspects of the game. So here we've got all different considerations. The grappling gun, which is our core. So if we followed the diagram at the top, A, launching the grappling gun hook at the target, B, hits the target, C, how would you want to use the grappling hook? So then if you fail, you may fall. If that happens, how can you move forward if it actually gets to the spot you're aiming for? So we also need to take up more, and these aren't slides that I've put, but we have a little bit of extra time. We then inform the user with how our UI is going to be. How is it going to, we can aim and shoot and if things get successful if they hit. And we talked a little bit about that with the trajectory slide, which you can see here. So just for a quick recap, because unfortunately I've sped up a little bit and this is pretty much what I have to talk about. Well, first of all, we talked about nesting, talked about how there's core, secondary, and tertiary. This is just my quick recap before I end. Again, taking the romance out of writing, you can see just by the examples that I've shown how with design, it's more about mapping out positives and negatives, or which I feel when you talk about mechanics. So again, we can see that we're not so much going to write. It's more that we are laying out paths. I think design has a good process of, if you live at a house and you've got Woolies and there's like 27 different rows or paths that you can take, we allow in-game that type of choice to have, where you still end up at Woolies, but it may take a 1 minute trip to a 5 minute trip. But people will always say, oh, this road's faster or this one's slower. This is a diagram which Craig made, and I think it explains it perfectly. So we'll just go back to that with our recap. So core loop, this is how you approach game design, not necessarily from the point of view that it's all about this person who does this. It's more about, do you do A and B, which then will make C or D or E happen. You can see that you're mapping out the path. Okay. And then just because I like the diagrams, we'll just recap on this one as well. So you can see how one core mechanic gets developed. You can see how that all gets grouped together, and then your secondary, as we talked about, is a supporting role. And then you can see how your tertiary basically starts to put things together, story points, cinematic, boss battles, and so on. Again, if you really want to get into design, I personally believe that if pick the worst game, even the worst game you've ever played. Don't pick the best one, pick the worst one, and then start to break it up into the core, the secondary, and the tertiary. And then really start to think about how the whole process was made for the game. Out of everything we do, balance. Balance and flow of play is what's going to make the fun. So in design, you'll find a lot of people say, oh, let's find the fun factor or the fun of things. To a certain degree, first of all, you need to be able to have something to work with to be able to find the fun and to make changes with. And you'll find that with the process. Maybe the original idea that you had or the concept might be stuck to when you work on the core mechanics or your prototype, but things will always change and develop. And so the game that you are working on may not be the exact finished title that you've done. In fact, I don't know many games at all off the top of my head where their original idea has stayed all the way through. There's always changes to be made. That's what's really good about this whole process and why we call it a living, breathing document for design. Okay, so just to go back down, when you're doing mechanics, remember before the gameplay is in place, the idea itself needs to be implemented. The other streams such as artists and programmers need to work from the limitations that the designer has provided. So really, you're not thinking about just all the positives. It's also what can't happen. So hopefully my wonderful displays as examples have helped. And we'll just go back to the last slide, which is again with the grappling gun. You can see how A, B, and C, and then the ifs it happens or if it doesn't, and we take that into it. All right, guys, thank you very much. I hope you've enjoyed it as much as I have, and I'll catch you guys later. Thank you very much.